Okay, in this video I'm going to go over the last problem that you were solving alone in your video lesson. So again, this was the problem. The average of two numbers is 39.625. One number is 1,500 times the reciprocal of the other number. Find the two numbers. So here are the two equations that I set up for myself. So the first is my average. The average of two numbers, so I define them to be A and B. And I'm adding them and dividing them by 2, so this is taking the average, is 39.625. So this is my first equation. Here's my second equation. The one number, so I just picked A, you could have picked B, it does not matter, is 1,500 times the reciprocal of the other number. So if the other number I've defined to be B, the reciprocal of B is just 1 over B. And I went through and I simplified that multiplication. So if I put 1,500 over 1, I'm just multiplying the numerators, multiplying the denominators. So A will equal 1,500 divided by B. Now at this point, similar to the last problem that we went over, you've got a systems of equations. So I've got two different equations with two variables. I can solve that. So since I know what A equals, I can plug 1,500 over B into A in this equation. So when I do that, I'll get 1,500 divided by B plus B divided by 2 is equal to 39.625. And you can see that I wanted to get rid of this 2 in my denominator. So I can multiply both sides by 2 and it'll cancel out. That way I'll be left with 1,500 over B plus B equals 79.25. So now I'm at the step where I want to combine these two terms, my 1,500 over B plus B. In order to do that, I've got to have a common denominator of B. So I have to multiply this term by B over B. When I do that, I'll end up with 1,500 plus B squared, so B times B gives me B squared, divided by B equals 79.25. So now I want to get that B out of the denominator, so I'm going to multiply both sides by B. When I do that, I'll end up with 1,500 plus B squared equals 79.25 times B. Now I want to get everything over to one side since I see I've got a quadratic equation because of the exponent. So I'm going to subtract 79.25b over to the left. When I do that, I'll end up with the equation b squared minus 79.25b plus 1,500 equals 0. In order to solve this, you guessed it, I'm going to use my quadratic formula. B equals negative 79.25 plus or minus the square root of negative 79.25 squared minus 4 times 1 times 1,500 all over 2. When I simplify this beast in here, I'll end up with 79.25 plus or minus the square root of 280.5625 over 2. The square root of this number simplifies down nicely. I end up with B equals 79.25 plus or minus 16.75 divided by 2. And when I go through and simplify that, so 79.25 plus 16.75 divided by 2, I end up at 48. When I subtract these two values and divide by 2, I end up at 31.25. Similarly to the last problem that we went over, when you actually go and plug these two values into your original two equations, it does not matter which one is A and which one is B. So I can just self-assign. I can say A equals 48 and B equals 31.25, or A can equal 31.25, B can equal 48. Both will work when I plug them into all of our equations. And that's it. Like I said, we're going to go over a couple more problems like this tomorrow in class, and go over a couple of different types as well.